I'm out here at Marmong Point Marina and we're going to go out on the boats and do a bit of a project, but this came about because I met a couple of people down at Manly Cove just recently looking at microplastics in the environment, and I was really lucky to be introduced to Favour, who we'll be talking to soon, from the University of Newcastle, and then to meet Madison Carberry. Now Madison's a PhD student and she's looking at microplastics in the environment and how they're affecting the environment. So we've arranged to go out here on Lake Macquarie this morning and actually have a look at it. So Madison, could you tell us quickly about what you're doing?
Yeah, sure. So I'm looking at microplastics in marine food web, which basically there's a few parts to the project. So it begins doing spatial assessments of microplastics in Australian aquatic environments. So looking in Lake Macquarie, Newcastle Harbour and Port Stephens as well. And then looking at the contaminants that are sorbing onto the plastic particles as well, because they do interact with metals and different types of contaminants in the estuarine waters. And then I'll actually be feeding these microplastics through a food web.
So at the moment we're just surveying the surface waters for microplastics. So the most commonly produced plastic polymers tend to float. So that's your polyethylene, polystyrene, polypropylene, so your plastic bags and straws and those sorts of things. They sit in the surface of the water column, and so by using this method we're able to sort of quantify how many plastics there are over a certain distance.
And we are actually seeing a lot of rubbish, particularly along the sides of the creek. So that's what you would expect, unfortunately. But how that's translating into microplastics in the water column, we don't know at this stage. So I'll be really interested to see what we pull out of this.
Microplastic is anything below the size of your fingernail.
Yeah, well, we should talk about that. It's 5 millimetres. Is that the figure you use? 5 millimetres?
That's
below 5 millimetres?
That's the standard figure.
Yep.
That's not definition. It's a broad range.
Yep.
But most often we find around 1 to 2 millimeter size, not as big.
1 to 2. Yeah.
But it's difficult to define because these plastics keep degrading, breaking down. So it goes to micro, nano, pico range.
Just very quickly, the process of breaking down plastic. I was actually asking you about this, and I thought the UV light would be one of the big factors. But you're saying there's mechanical factors, chemical factors.
Physical, mechanical, chemical, biological.
Okay.
Those 4 factors commonly known to cause this breakdown.
This is a much more complex issue than what most people know, and I'm really sort of learning a lot just from talking to you and talking to Favour about this, because people know about plastics and they think about marine animal ingestion and entanglement and things like that. So we're talking about the, I guess, more iconic creatures that they think about, turtles and fish,
more
sharks,
charismatic organisms,
and certainly further up the food chain. But microplastics are getting into the filter feeders.
They are.
So we're going right through the food chain, I imagine.
Exactly, yeah. So they are. There have been quite a few studies. Some are actually from the natural environment, netting zooplankton out of the ocean, and scanning them for microplastic particles, and they are detecting them in quite a few species.
Bottom line is, there's so many plastics in the environment. A lot of it is,
and it's going to keep getting worse.
A lot of it is in microplastics, but all the plastics are out there as they break down, are turning into microplastics.
Exactly.
So the problem is only going to get worse before it can get better, and can only get better if we recognise that it is a problem. The threat that microplastics pose to both the environment and to human health are not yet fully known. However, the avalanche of relatively recent evidence against them is a clear indicator that the risks are huge, and to a large extent, damage already done is irreversible. We all know that plastics pose a huge threat to our oceans, rivers, lakes and other waterways. Many would have heard of the Great Pacific Garbage Patch and would have seen shocking and sad images of sea life living with and dying from plastic items. It is estimated that each year around 12 million tonnes of plastic is dumped into the world's oceans. It kills around 1 million seabirds and 100,000 marine mammals after they are either entangled and strangled or choked and starved annually. But perhaps what people don't know is that research shows more than 85% of the plastic in the environment is microplastic, with trillions and trillions of pieces already in our oceans. Microplastics are any piece of plastic measuring less than 5 millimetres in size and come from a variety of sources. They include microbeads, which can be found in some cosmetics and other products, but can also be pellets, powders, industrial scrubbers and bits of plastic that are broken off or broken down from larger pieces of plastic, such as car tyres, fibre from clothing, or nearly anything really, though perhaps even more worrying than larger pieces of plastic. Have no doubt that microplastics have entered our food chain. As Madison said earlier, they have been found inside zooplankton, but also microplastics have been found inside oysters, mussels, and canned fish being sold in supermarkets. Microplastics have also been found in honey, of all things, bottled water, beer, chicken, and salt. The impact that plastic and microplastics are having on our world is really a sleeper issue. We simply don't know what the repercussions are. It's worth noting that mass production of plastic only began in the 1950s, and that plastic does not biodegrade, it only breaks into smaller pieces. We're only just beginning to understand the catastrophic possibilities this man-made substance could have. While there are lots of problems with plastics in our environment, the fact is that plastics are essential to modern life, including in areas such as medicine and medical devices, computer technologies, food technology, aircraft, motor vehicles, and pretty well all areas of modern life. Plastics are essential and amazing, but we need to ensure that every plastic has a full life cycle of reuse or destruction that doesn't include being lost to or damaging the environment. And that's why studies such as OSMAP and those being undertaken by Madison and Farber at the University of Newcastle are so important.
So basically my project is sort of looking at the contamination of marine food webs and the potential impacts on human health. So what is the potential of these plastics to actually transfer these contaminants that they're accumulating from the environment if they are consumed by marine organisms? What are the impacts to those organisms? And then if they are bioaccumulating in things like oysters and fish and seafood items that we're actually consuming, what does that mean for us as the apex predator in the food web? What are the health implications? So there's already quite a bit of research on plastic additives, so things like BPA, which is a hardener in plastics, and phthalates, which is actually a softener in your cling films and those sorts of things. They have carcinogenic and mutagenic effects as well. But the actual plastic as the medium, as the transport vector, we don't know a lot about. And it's one of those things that have just come onto the market, they've flooded onto the market within a period of 70 years, and now we're starting to see the impacts in the environment, but also starting to become aware of the potential human health impacts. And I think that's when people start to pay attention, and that's when the momentum starts happening around research of these things.
This is one part of my PhD. We have identified 6 sites in Lake Macquarie which have different pollution. So these are the plastic we collected from different parts of Lake Macquarie, Dora Creek, Cockle Creek, which are too much polluted by anthropogenic litter, which is plastic, one of them. And the most serious thing about plastic pollution is it is covered with biofilms, means microorganisms. So when fish and other animals, they actually see them or they actually smell them, it smells like food to them because the food is also covered with these biofilms. Now, that's why plastic is actually going into their gut. They are ingesting plastic, and this is a serious concern because if they are eating plastic and all the seafood which we actually ingest, it's going in our gut. So it also has implications on human health.
Yeah, I think education and research are the two biggest players in trying to reduce the problem of plastic. So obviously you need people at the end that aren't quite as good as communicating the findings or the potential risks of plastic, and then if you pair up with educators, then obviously if you're getting into schools and getting out to the public and just educating people on why we should reduce our plastic consumption and just making smarter choices, then hopefully we can do a lot for the planet.